Good morning, students, and happy snow day. Yeah, it's a snow day. Not so sure how much we needed this said snow day, but hey, um, what are you gonna do? I hope you're enjoying your day at home. I was looking at pictures of snow days to just show in the video, and I was reminded of a great great movie that used to be popular when I was little, called literally Snow Day. It was a Nickelodeon movie. If you haven't seen it, go see it now. Ignore the ratings. It's a great movie. You should go watch it. All that being said, we have a quick lesson here that we're going to do on parallelograms. If you remember, this shouldn't take you too long. The notes are on haiku, so if you want to print them off so that you can write down on them, that's fine. But you don't have to print them off either if you don't want to. You can just take notes on paper. If you remember, this chapter 6, is on quadrilaterals, different types of quadrilaterals. So, and last section was on polygons. We introduced the idea of what a polygon was. So what we're doing now is we're just introducing different types of quadrilaterals. The first one that we're going to introduce is a parallelogram. Okay, so this is only 4 slides. Shouldn't take you too long. But a parallelogram is a quadrilateral that has both pairs of opposite sides being parallel. Both pairs of opposite sides are parallel. Here's what that means. In order for something to be a parallelogram, then this side must be parallel to this side. And similarly, this side must be parallel to this side. And all of that is shown in this picture right away. If you remember, these little arrows indicate parallel. So what this is saying right here and right here is that these sides are parallel. And what this is saying right here, since there's 2 of them, that all of the sides that have 2 arrows are parallel. So this is just the definition of a parallelogram. If you have your definition sheet, I'm not sure that you would, but this is something that you could totally add to your definition sheet, okay? That a parallelogram is a quadrilateral, a 4-sided polygon that has both pairs of opposite sides being parallel. Okay, let's move on. Theorem 6.2 says, if a quadrilateral is a parallelogram, then its opposite sides are congruent. So here we could also say, we don't just know that these are parallel, we could also know that side AD is also congruent to its opposite side, which is BC. And that's one pair of opposite sides, and DC is congruent to AB. So if it's a parallelogram, it's not only parallel, but it's also congruent. I'm going to add my tick marks. The sides are not just parallel, they're also congruent. All right, moving right along. If a quadrilateral is a parallelogram, then its opposite angles are congruent. Okay, so it's opposite angles. So here's angle A. What angle is opposite of angle A? Well, it's the angle that's in the diagonal. So the opposite angle of A is C. So if this is a parallelogram, which it is, we're given that both pairs of opposite sides are parallel, then we can know for certain that angle A is congruent to angle C, and angle B is congruent to angle D. All right. So we know that the opposite sides are parallel and congruent. We also know that the opposite angles are congruent in a parallelogram. All right, here we go. We're getting close. 2 more slides. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Okay, here's what it means. All right. Its consecutive angles are the angles that are next to each other. The angles that are next to each other. So in other words, Angle A here. Let's start with angle A. Angle A has two angles that you would say are consecutive with it. Since it is next to both angle B and angle D, we would say both angle B and angle D are consecutive to A. And what we would be saying here is that angle A is supplementary with angle B and angle D. And that should make sense to you, right? Because what we now know is that angle D and angle B are the same thing, right? They're congruent because they're opposite angles. So if angle A is supplementary with B, then angle A would have to be supplementary with D. So the consecutive angles in a parallelogram are supplementary. We could go around and write out all of the pairs of supplementary angles that we have here, but we're not going to do that. I'm just going to show you and talk you through it. So we would say that A plus B is 180, A plus D is 180, D plus C is 180, and C plus B is 180. All those, we have four pairs of consecutive angles that are supplementary anytime we have a parallelogram. Okay, so once again, that's A and B, A and D, D and C, and B and C. All of those are consecutive angles, so they're all supplementary. They all add up to 180. All right. If a quadrilateral is a parallelogram, then its diagonals bisect each other. Now, this one's a little bit different. This one is just a little bit different, and this is a really important rule that actually helps architects all of the time when they're constructing buildings. If you think they are constructing buildings that are mostly made up of squares or rectangles, or every rectangle, if it's a perfect rectangle, it's a parallelogram. So architects and contractors use this rule all the time to make sure that buildings are properly constructed. But here's what they said. These diagonals exist whether I draw them or not. So for example, there are diagonals in this parallelogram here. We just haven't necessarily drawn them. So just because I haven't explicitly gone through and drawn the diagonal, that was poorly drawn, but you get the picture, doesn't mean that it's not there, okay? So if a quadrilateral is a parallelogram, then the diagonals cut each other in half. Remember, bisect means to cut in half. So what does that tell us? Well, if these cut each other in half, then we know that AP has to be congruent to PC. If DB perfectly cuts AC in half, then these two things have to be congruent. And similarly, if AC perfectly cuts DB in half, then these two segments have to be congruent. All right? So we know a lot about parallelograms. First, we know that their opposite sides are parallel to each other. Second, we know their opposite sides are congruent. Third, we know their opposite angles are congruent. Fourth, we know that their consecutive angles are supplementary. And fifth, their diagonals bisect each other. So just by the fact of knowing that this is or is not a parallelogram, we can know a lot about parallelograms. All right. So what we have is a couple practice problems here. All right. So we're going to walk through this first one together, and then I will leave you to do the second one on your own. Okay. ABCD is a parallelogram. Let's see. How else could you solve for X and Y? We're going to solve for X and Y. There are lots of different ways that we could solve for X and Y here, given my hidden comment, and I'm going to go ahead and get rid of that. What's the way that you see right away that you could solve for X and Y? Well, there's multiple ways, so the way that we do it together is not necessarily the only one and right way, but the way that jumps out to me is I remember that the opposite angles in a parallelogram are congruent. So one thing that I could do is I could just set these different angles equal to each other and then solve. So if those are congruent, whoa, weird Y. if A and C are congruent, then that means 3y plus 18 and 4y minus 9 has to be congruent. And similarly, x minus 20 and 81 has to be congruent. How else could I solve for x and y? Well, remember, the consecutive angles are supplementary. So I could set up an expression right here if I wanted to with these two angles. I could add those angles together and set them equal to 180 and solve for y. And similarly, I could set those two angles, add those two angles together, set them equal to 180 and solve as well. I'm not going to force you to do whichever one you want. So pick which way you'd like to solve and go ahead in your notes and solve for these angles, or solve for x and y. Okay, and then I'm going to intro this problem and I'm going to have you do it on your own. If xu is 15 and uw is 28, then find wz and vw. Here's that on the picture. Here's xu. If xu is 15 and uw is 28, then it's asking you to find wz and vw. All right? And then you'll work your way through this problem. I want you to go ahead and do 1, 2, and 3. And when we go to class on Thursday, this is the first thing that we will do. All right, thank you guys for doing this. I tried to keep this as short as possible. I hope you enjoy your day. There's no practice problems. I'm not going to make you do practice problems at home. Just watch the lecture, take notes. Thanks, guys. See you tomorrow.